Voyager 1 is the first spacecraft to reach interstellar space. It originally was launched along with Voyager 2 in 1977 to explore the outer planets in our solar system. However, it has remained operational long past expectations and continues to send information about its journeys back to Earth. The spacecraft officially entered interstellar space in August 2012, almost 35 years after its voyage began. The Discovery wasn't made official until 2013, however, when scientists had time to review the data sent back from Voyager 1. Voyager 1 was actually the second of the twin spacecraft to launch, but it was the first to race by Jupiter and Saturn. The images it sent back have been used in school books and newspaper outlets for a generation. Also on board was a special record, carrying voices and music from Earth out into the cosmos. Voyager 2 launched on August 20, 1977, and Voyager 1 launched about 2 weeks later, on September 5. Since then, the spacecraft have been traveling along different flight paths and at different speeds. The Voyager missions were intended to take advantage of a special alignment of the outer planets that happens every 176 years. It would allow a spacecraft to slingshot from one planet to the next, assisted by the first planet's gravity. Infographic: how the Voyager space probes work. The spacecraft's next big encounter will take place in 40,000 years, when Voyager 1 comes within 1.7 light-years of the star SE79 3888. The star itself is roughly 17.5 light-years from Earth. However, Voyager 1's falling power supply means it will stop transmitting data by about 2025, meaning no data will flow back from that distant location. An artist's illustration of NASA's Voyager 1 spacecraft, the farthest human-built object from Earth, which launched in 1977 and is headed for interstellar space. Credit NASA. NASA originally planned to send 2 spacecraft past Jupiter, Saturn and Pluto, and 2 other probes past Jupiter, Uranus and Neptune. Budgetary reasons forced the agency to scale back its plans, but NASA still got a lot out of the 2 Voyagers it launched. Voyager 2 flew past Jupiter, Saturn, Uranus and Neptune, while Voyager 1 focused on Jupiter and Saturn. NASA's twin Voyager spacecraft launched in August and September 1977. Aboard each spacecraft is a golden record, a collection of sights, sounds and greetings from Earth. There are 117 images and greetings in 54 languages, with a variety of natural and human-made sounds like storms, volcanoes, rocket launches, airplanes and animals. Credit NASA. Recognizing that the Voyagers would fly out of the solar system, NASA authorized the production of 2 records to be placed on board the spacecraft. Sounds ranging from whale calls to the music of Chuck Berry were placed on board, as well as spoken greetings in 55 languages. The 12-inch gold-plated copper discs also included pictorials showing how to operate it, and the position of the Sun among nearby pulsars in case extraterrestrials were wondering where the spacecraft came from. Voyager 1 almost didn't get off the ground at its launch, as its rocket came within 3.5 seconds of running out of fuel on September 5, 1977. But it made it safely, and raced past its twin after launch, leaving the asteroid belt before Voyager 2 did. Voyager 1's first pictures of Jupiter beamed back to Earth in April 1978, when it was 165 million miles away. To NASA's surprise, in March 1979 Voyager 1 spotted a thin ring circling the planet. It found 2 new moons as well, Thebe and Metis. Additionally, Voyager 1 sent back detailed pictures of the Galilean moons Io, Europa, Ganymede and Callisto, as well as Amalthea. Like the Pioneer spacecraft before it, Voyager's look at Jupiter's moons revealed them to be active worlds of their own. Voyager 1 came out with some intriguing findings, as well. Ice volcanoes and mottled yellow-brown-orange surface were intriguing finds, proving that, like planets, moons could have active interiors. Additionally, Voyager 1 sent back ephemeral pictures of Europa showing a smooth surface broken up by lines, hinting at ice and maybe even an ocean underneath. Voyager 1's closest approach to Jupiter was on March 5, 1979, when it came within 174,000 miles of the turbulent cloud tops. Then it was time to aim for Saturn. Scientists only had to wait about a year, until 1980, to get close-up pictures of Saturn. The ringed planet turned out to be full of surprises. One of Voyager 1's targets was the F-ring, a thin ring discovered only the year previously by Pioneer 11. Voyager's high-resolution camera spotted 2 new moons, Prometheus and Pandora, whose orbits keep the debris in the F-ring in a defined orbit. It also discovered Atlas, and a new ring called the G-ring, and took images of several other Saturnian moons. One puzzle for astronomers was the moon Titan. Close-up pictures of the moon showed nothing but orange haze, leading to years of speculation about what it was like underneath. It wouldn't be until the mid-2000s that humanity would send the probe Huygens into the haze. With Voyager 1's primary mission over, the focus shifted on tracking the small probe as it sped out of the solar system. Voyager 1's official departure from the solar system occurred in August 2012. The discovery was made public in a study published in Science the following year. The results came to light after a powerful solar eruption was recorded in Voyager 1's plasma wave instrument between April 9 and May 22, 2013. The eruption caused electrons nearby Voyager 1 to vibrate. From the oscillations, researchers discovered Voyager 1's surroundings had a higher density than what is found inside the heliosphere, or the region of space in which the Sun's environment predominates. It seems contradictory that electron density is higher in interstellar space than it is in the Sun's neighborhood, but the researchers explained that at the edge of the heliosphere, electron density is dramatically low compared with locations nearby Earth. Researchers then backtracked through Voyager 1's data and nailed down the official departure date sometime in August 2012. The date was fixed not only by the electron oscillations, but also by its measurements of charged solar particles. On August 25, the probe saw a 1,000-fold drop in these particles and a 9% increase in galactic cosmic rays that come from outside of the solar system. At that point, it was 11.25 billion miles, 18.11 billion kilometers from the Sun, approximately 121 times the Earth-Sun distance. As of May 2017, Voyager 1 is roughly 137.8 astronomical units Earth-Sun distances from Earth. That's roughly 20.6 billion kilometers, or 12.8 billion miles. Further reading: real-time odometer. Where are the Voyagers?